3.
Yes.
Okay.
Very good. Okay. So I'm going to give you a problem here. How many, or actually, let me ask you, how far up do you know your square roots or squares?
I mean, just the basic
Like,
2 or 4, 8, 12. I can do up to like 60, 144, I think.
Okay, good enough. All right. So here's the question. What two let me be clear here. What two whole numbers is the square root of 55 between? So
22 and 23.
Okay, so let me try to answer that differently. Let me show you an example here. The square root of 2 falls here. Do you agree that it falls between 1 and 2?
Yes.
The square root of 5 falls between 2 and 3.
Yes.
And the square root of 9 falls between 3 and 4.
Yes.
So I'm looking for an answer here like 1 and 2 or 2 and 3 or 3 and 4.
22 and 23.
Okay, so let me try to help you out here. What is 7? What is 7 squared?
7 squared is 49.
Okay, so the square root of 49 is?
It's 7.
Okay, what is 8 squared?
64.
Okay, and the square root of 64 is?
8.
So on a number line here, if this is 7 and this is 8, this is really the square root of 49 and the square root of 64. The square root of 55 is somewhere in the middle. Would you agree?
Yes.
So it falls between, which two whole numbers does it fall between?
7 and 8.
Good. So that's what I was trying to get you to answer me for that. Which two whole numbers does it fall between? So the answer I was looking for is 7 and 8.
Okay.
I feel like Alex Trebek here. A little bit. All right, you ready to try another one?
Yep.
Okay. Square root of 113. So which two numbers does that fall between?
I 5 and 6.
Okay, 5 squared is 25.
Oh,
6
no,
squared
no.
is 36. You're way too far away. You're on Saturn right now.
Okay. Okay.
That's why I asked how far up did you know?
12 and 11.
What is 11 squared?
11 squared. 11 times 11 is 100 and I can't remember. I can't remember that one.
Do you have some paper you can work this out on?
Yeah.
Okay. You want to know up to, you're a good math student. You should probably know up to 15 for sure. 15 squared. You may want to know up to like 20 or 25 squared. I'm not sure if you heard what I just said. How were you?
Oh, was I muted?
No, I hear you now.
Oh, okay.
All good. All good.
121. Okay.
So that's too big.
Oh, okay. 10 and 11.
Yes.
Okay.
So this number is between 10 and 11.
Oh, I get it. Okay.
Okay. All right. Now let's try another one here. How about the square root of let's see, 32?
Square root of 32 would fall between 5 and 6.
Okay. Now, if you had to make a guess, is it closer to 6 or closer to 5?
6.
And how are you making that decision?
Well, it's at least in the 30s, and 6 times 6 is 36.
Right. So we're basically deciding like it's 7 away from 25, but 4 away from 36.
Yes.
Does that make
Yes, that makes sense.
Okay, now, have you ever seen a graph of square root?
Never a graph.
Well, we should look at that. Let me get that up here. Just a moment here, getting it to where I can graph this. All right, let me go to. All right, so y equals square root of x. Have you seen this graph before? Kind of goes up and to the right.
Not that exact graph, no.
Really?
Yeah.
Okay. So what I've done here, and actually let me bound this thing from right here so we can look at it. Let's think of this in terms of if you were climbing. What do you notice about the climb at the beginning?
It's very steep.
And then what happens here?
It flattens out a little bit more.
Yes. Okay, so because these are fractions, some of the rules don't apply here, but let me go from 1 to 4 now, and let's see if the same thing holds. Okay, let's see if it also looks, and I got to just reframe this here. How does this compare to what we just said? Would you agree that it has some of the same tendencies, or is
Some
it
of the same tendencies.
Yeah, some of the same tendencies. So, but it's not quite as pronounced, right?
Yeah.
So if we say x equals the square root of 3, and then x equals the square root of 2, do you see how those are closer to 1?
Yeah.
Which is down here.
Yeah.
Okay. So it's not quite linear, I guess, was what I was trying to show you, is like you can't just like automatically justify it, but the way these typically work in the problems you'll see is they will give you one that's closer to one of the edges than the other. All right, so let's go back, do some more problems here. So let me give you a more difficult one. How about negative square root of 41? What two numbers is that between?
Negative square root of 41. 7 and 6.
But this is negative.
Oh, -7 and -6.
Like this?
No, reverse.
Which is smaller, -7 or -6?
A negative. Oh, -7. Sorry.
Yes. Smaller to larger. Good. Very good. Okay, so you understand all that. So the square root of 1, which is 1, the square root of 4, which is 2, these are considered rational.
Okay.
Have you heard that word before, rational?
Yeah.
It means you can write it as a decimal that terminates. So one way to look at it, but the square root of 3, square root of 5 is actually irrational. What does that mean?
It cannot be turned into a decimal or fraction.
That's right. So that poses some serious problems when doing computations. But that's sort of a side point there. So good. Okay, let's go look at these special triangles. So the idea behind this is that in a right triangle, if I give you 2 sides out of the 3, you can always find the third side. Would you agree with that?
Yeah.
And that's called the Pythagorean theorem. A, B, C, a squared plus b squared equals c squared. But I have to give you 2 of 3. In a 30-degree, 60-degree, 90-degree triangle, I actually only have to give you one of the sides. From one side, you can actually find all the others.
Oh.
Okay. You might be like, how does that even work? So I'll
Yeah.
show you. I'm sorry?
I am.
Yeah, it's kind of amazing. These have some special properties, right? And that means you see a lot of them in math class here. So the if the short leg, what's called the short leg, is always across from the 30. Okay.
Mhm.
The hypotenuse is always across from the 90. The hypotenuse is double the short leg. Just double it. So let's say this is 10, this would be 20.
Okay.
The long leg is the short leg times the square root of 3. So again, if this is 10, the hypotenuse is 20, this is 10 square root 3. The long leg is always across from the 60. So there's this theorem in geometry which says the longest side, which is the hypotenuse, is across from the longest angle or the biggest angle. The shortest side is across from the shortest angle. Okay, so that's how you know which one it is. If it's the short side, it's across from the 30. The hypotenuse is always across from the 90, 60 is across from this.
Okay. I think I understand.
All right. So let's do an example. We kind of already mentioned that, so we'll just use that here. So let's say the short leg is 10. The hypotenuse is 20. And the long leg is 10 square root 3. Do you think a squared plus b squared equals c squared? Do you think this still holds?
No.
Let's try it out. A, b, and c. A is 10, 10 squared, plus b, 10 square root 3 squared. C is 20. 10 squared is 100. Do you remember how to square something like this? I'm not sure if you've seen that before.
No, I don't think
So
so.
you square the number, and then when you square a square root, it undoes it.
Oh.
So it's 100 times 3.
Okay.
So this becomes 300. What is 20 squared?
20 squared is 2,000 or
Try again.
1,000.
Try again. 20 times 20.
0. Oh, 200. Hold on, give me a minute to write this out on paper.
Yeah, please do.
Times 20, 0, 0, x, 0, 4, 400.
So does this hold?
Yeah.
So this always works.
Okay.
Are you familiar with the, sometimes they say this in the, like the, I don't know, the, what do I call it? Like the automotive world, like a hammer always works. Like the Pythagorean theorem is like your hammer, like it will always work. You'll always get the job done, but it may not be the best tool, right? Like you want to open your door and you got a hammer, like it might work, but might not be the best tool. So these other triangles are the 3069s are another tool to solving these triangles, but they both have to hold.
Okay.
Like one can't work for the other. So let's try another one here. Let me make this slightly different. Let's say this is 15 and this is 5 square root 3. Can you find c for me, please? And I want you to use a squared plus b squared equals c squared.
Okay. Okay, so 15 times 5 square root of 30. So 5 squared times 3 squared. So that's 25 times 9.
Are you squaring? Are you calling this a?
No, that's b. I haven't, because you can't do that if you don't like.
So just to be clear,
Oh.
you're squaring 5, which is fine. But when you square the 3, it just undoes it.
Yeah, I'm
So
making.
it's just,
Oh, it
just
doesn't
becomes
have
3.
any function. Okay.
Yeah, it undoes it. It's like when you subtract and add, they undo each other.
Okay. So 5 times 3.
5 squared
Oh,
times
yeah. So 25 times 3 is 75.
Okay.
So 15 times 75 equals 5, 7x. Okay. No. Yeah, 35. 1, 7.
So what is 15 squared?
Oh, 15. Oh, 15 squared. I messed it up. Okay, 15 squared is 15 times 15, 25, carry the 2, 5, 7, x, 5, 1 plus, okay, 5, 12, 2, 225.
Yes.
225 plus 70 or plus what's it called? 75, yes.
Okay, we talked about how to take square roots that don't work, how to reduce them.
Square roots that don't work.
Like the square root of 300 is not known. Did we talk about how to reduce roots?
I don't think so.
Okay, that's not good. All right. Oh man, I guess we can't do this. I thought we could get into this, but we really need to talk about that. I'm just shocked your teachers do this. Okay, so let me refresh here. Apologize. I would have spent more time on that. Okay, let's go through this again. So let's say it's a 30, 60, 90. 30 degrees, 60 degree, 90 degree. If I give you the short leg, the hypotenuse is double the short leg, and the long leg is the short leg times the square root of 3. Okay, do you have this written down, or do you have this kind of
Yes.
where you get it? Okay. All right, so I'm going to give you some problems here, and I want you to find the missing sides. You'll see what I mean here in a moment. So let's say I give you something like this. This is 8. I want you to find, and this is 30 degrees. I want you to find A and B for me, please. So this time you have to use the 30, 60, 90.
Okay. That's 30 degrees, 60, 90. Okay. 8, A, B. So
8 is 8 the short leg, long leg, or the hypotenuse?
the hypotenuse.
The hypotenuse is always across from the 90.
Oh, oh, that's the short leg then.
Yes.
Okay.
So how do you find the hypotenuse from the short leg?
The hypotenuse from the short leg, double multiply it times 2.
Yes. Very
Okay.
good.
16. So B equals 6.
Good. And A?
Long leg times long leg times square root of 3.
Short leg times the square root of 3. 8 square root of 3. Okay, now let's verify that the Pythagorean theorem actually works here. So is 8 squared plus 8 square root 3 squared equal to 16 squared?
Let me see. 8 squared equals 64. So 64 plus 8 times 3. 64, no, 8 squared times 3. So that's 64 times 3. 64 times 3 equals 4, 8, 12, 2, 1. Okay. 192. So 64 plus 192 is 6, 5, 1, 250. 16 squared equals. Oh, I'm already off.
Yeah, I think you're adding. You said the right numbers. You just wrote down the wrong result.
Oh no, sorry. That's supposed to be a 6. Oops. Okay.
So this one does in fact work. Okay, let's try another one real quick in the time we've got left. Let's say this is 12. No, I did not do that. Okay, I just did the same problem. All right, this is 30 degrees. I want you to find A and B for me, please. So am I giving you the short leg, long leg, or hypotenuse? You may be muted currently.
It keeps doing that. You've given me the hypotenuse.
Yes. So how do you find the short leg from the hypotenuse?
The short leg from the hypotenuse.
Or what do you do to the short leg to get the hypotenuse?
Oh, you multiply it by 2.
So how do
So
you undo multiplication by 2?
division by 2,
You got it.
which is 6.
Okay, so B is
So-
6.
6. So we've got the short leg. So A equals 6 times 3 squared.
Square root of 3.
Or yeah,
So is 6 squared plus 6 square root of 3 squared equal to 12 squared? Go ahead and verify that for us, please.
36 times 3. 36 times 3 equals 18. Carry the 1, 3, 9, 10, 108. 36 plus 108. Okay.
That equals 144, which is
Okay.
144. Good.
Okay.
Okay, we do have to stop there. Lewis, great job though. Let me stop the recording here.